In the silent, unending dark between the worlds, where time itself seems to stretch and thin, there are empires of light. They are not built of stone or steel, but of suns and dust, bound by a force that is both architect and destroyer. We call them galaxy clusters, the great, glittering cities of the cosmos, the most massive gravitationally bound structures in the known universe. From our distant vantage point, they appear as serene, jeweled tapestries, ancient and unchanging. But this tranquility is an illusion, a mask worn over a history of unimaginable violence and a cycle of life and death played out on scales that defy human comprehension. Deep within one such metropolis, 57 billion light-years away in the constellation for which it is named, lies the Phoenix Cluster. For eons, it slumbered, a giant breathing in the slow rhythm of cosmic time. But something stirred in its heart. A power was unleashed, an eruption of such titanic force that it tore a wound in the very fabric of the cluster, a scar visible across billions of light-years. This was not the death of a single star, a supernova that flashes and fades. This was an outburst of energy equivalent to hundreds of billions of supernovae, sustained over millions of years. It is, to this day, the most powerful energetic event ever detected in the universe since the Big Bang itself. It was a cosmic roar that echoed through the void, a message from the deep, dark heart of a galaxy. It created a cavity in the space between galaxies, a ghostly bubble of nothingness hundreds of thousands of light-years across, a void so vast our own Milky Way galaxy could fit inside it twice over. What kind of engine could generate such power? What force could awaken from its slumber to reshape an entire galactic ecosystem on a scale so grand? The answer lies not in a star, but in the monster that consumes them, a supermassive black hole, a sleeping tyrant that, when starved for too long, finally woke to feed. And in its feeding, it reminded the universe that the greatest acts of creation are often born from the most profound moments of destruction. This is the story of that eruption. It is a story of a delicate, cosmic balance, of a hunger that builds over ages, and of the inevitable, violent release that restores order. To understand it, we must journey into the heart of the Phoenix, past the swirling veils of galaxies, through an ocean of invisible fire, and come face to face with the quiet god of gravity that reigns at its center. We must learn to see the universe not as a static portrait, but as a living, breathing entity, locked in an eternal struggle against its own decay. Join us as we unravel the mystery of the greatest explosion ever witnessed, and listen for the echoes of its power, still ringing through the cosmos today. Now, let's begin. The Phoenix Cluster, officially designated SPTCLJ 2344-4243, is not merely a place, it is a dominion. To gaze upon it through our most powerful telescopes is to look back in time 57 billion years, to witness a kingdom of light when our own sun was yet to be born. It is a metropolis of staggering proportions, a gravitationally bound archipelago of over 1,000 galaxies, each one a swirl of billions of stars, planets, and nebulae. These galaxies are the citizens of the cluster, moving in slow, majestic orbits around a common center of mass, their paths dictated by a force they cannot see but can never escape. This force is gravity, the silent, invisible sovereign of the cosmos. But the visible galaxies, as brilliant as they are, represent only a tiny fraction of the cluster's true substance. They like luminous ships sailing on a vast, unseen ocean. This ocean is the intracluster medium, or ICM, a tenuous, searingly hot plasma of gas that fills the immense voids between the galaxies. It is a ghost sea, invisible to the naked eye, yet it is here that the vast majority of the cluster's ordinary, baryonic matter resides. This gas is the cluster's atmosphere, its lifeblood, and its memory. Heated to tens of millions of degrees by the gravitational potential of the cluster itself, it glows not in visible light, but in the high-energy realm of X-rays. To see the Phoenix Cluster in X-rays is to see its true form, not as a collection of disconnected islands of light, but as a single, cohesive, glowing entity, a colossal cloud of incandescent gas, with the galaxies embedded within it like scattered jewels. This medium is the repository of cosmic history, enriched with heavy elements forged in the hearts of countless generations of stars and flung into intergalactic space by supernovae. It is a chemical record of the cluster's long and violent life. And yet, even this great ocean of gas, combined with all the stars and all the galaxies, is not the dominant presence. The true scaffolding of this cosmic city, the invisible architecture that dictates its shape and its destiny, is dark matter. This mysterious, non-luminous substance, 5 times more abundant than all the normal matter combined, forms a vast, spherical halo around the cluster. Its gravitational influence is the ultimate authority, the hand that sculpted the cluster from the primordial soup of the early universe and the chain that binds its 1,000 galaxies together. It is a silent, formless god, and the luminous universe we see is merely the decoration upon its unseen temple. At the very center of this gravitational well, at the heart of the dark matter halo and the glowing ICM, lies the cluster's capital, a colossal central dominant galaxy, known as Phoenix A. This is not an elegant spiral like our Milky Way. It is a bloated, spheroidal giant, a cannibal that has grown to its immense size by consuming its smaller neighbors over billions of years. It is a galaxy of old, red stars, a relic of ancient mergers, sitting enthroned at the bottom of the cluster's gravitational pit. It is the focal point, the place where the cluster's destiny is forged. And within the heart of this giant galaxy, there lies an even greater power, a concentration of mass and gravity so extreme it defies the laws of classical physics. It is the engine of the story, the sleeping tyrant whose awakening would shake the very foundations of its kingdom. The entire structure, the galaxies, the ICM, the dark matter halo, is a single, interconnected ecosystem. It is a delicate balance of forces, a cosmic dance between gravity pulling everything inward and the thermal energy of the hot gas pushing everything outward. For billions of years, this dance continued in a state of relative equilibrium. The Phoenix cluster was a mature, settled kingdom, its most violent, formative years long past. Or so it seemed. But deep within the system, a slow, inexorable process was underway, a fundamental consequence of the laws of thermodynamics that threatened to shatter this ancient peace. A clock was ticking, counting down to a moment of cataclysmic change. The great ocean of the ICM, despite its immense heat, was not static. It was constantly radiating its energy away into space in the form of X-rays. It was, in essence, cooling. And in this slow, patient cooling lay the seeds of the greatest eruption the universe had ever seen. The stage was set, the characters were in place, and the plot, written into the laws of physics, was about to unfold. At the gravitational nexus of the Phoenix cluster, within the dense, star-choked core of the central galaxy Phoenix A, lies the ultimate expression of gravity's power, a supermassive black hole. This is not the stellar mass variety, born from the collapse of a single giant star. This is a monster of a different order, a behemoth weighing as much as tens of billions of our suns, compressed into a volume smaller than our solar system. It is a singularity, a point of infinite density where space-time itself collapses, and from whose grasp not even light can escape. We must abandon the popular image of a cosmic vacuum cleaner, aggressively sucking in everything around it. The truth is more subtle, more patient, and far more profound. This black hole is a slumbering monarch, its direct influence confined to the tiny region of its event horizon. Yet its presence defines the entire galaxy around it. The stars in the galactic core do not plunge into it, they orbit it, like courtiers around a throne, their paths a testament to the immense gravitational authority concentrated at the center. This entity did not appear overnight. It grew with its galaxy, a process of coevolution spanning billions of years. In the chaotic youth of the universe, when galaxies were crashing together in a frenzy of mergers, vast quantities of gas and stars were funneled toward the galactic center, feeding the nascent black hole and fueling its growth. Each meal, each swallowed star or gas cloud, added to its mass, increasing its gravitational reach and tightening its grip on the galaxy's heart. Over time, a symbiotic relationship was established. The black hole's growth was regulated by the galaxy's supply of fuel, and the galaxy's evolution, in turn, was shaped by the black hole's periodic outbursts of energy. It is a fundamental partnership that we now see as crucial to the formation of all large galaxies, including our own. For long epochs, the black hole in Phoenix A was in a state of quiescence. It was sleeping. The great feasts of the early universe were over, and its diet had become meager. But it was never truly dormant. A trickle of matter, a stray gas cloud, or an unfortunate star wandering too close, would be drawn in. As this material spiraled toward the event horizon, it did not fall directly. Instead, it formed a structure of breathtaking beauty and violence, an accretion disk. This is a flattened, spinning vortex of superheated plasma, a cosmic whirlpool where matter makes its final, incandescent journey. The gravitational shear is so intense that friction heats the gas to millions of degrees, causing it to blaze with a light that can outshine all the billions of stars in the host galaxy combined. This is the source of the brilliant light from quasars, the active hearts of young galaxies. But in the mature Phoenix A, the accretion disk was a mere whisper of its former glory, a faint, glowing ring sustained by a cosmic drizzle. The material in this disk, trapped in a gravitational dance of death, orbits at incredible speeds, approaching the speed of light near the inner edge. Here, the laws of physics are pushed to their limits. The intense gravity warps space-time, and the powerful magnetic fields embedded within the plasma are twisted into complex, rope-like structures. This tangled magnetic field is the key. It acts as a conduit, a mechanism for extracting energy from the spinning black hole and the infalling matter. It is a loaded spring, storing immense potential energy, waiting for the right conditions to be released. For millions, perhaps hundreds of millions of years, the black hole in Phoenix A slumbered on, its accretion disk glowing faintly, its magnetic fields churning quietly. It was a giant in repose, its power contained, its influence a gentle, gravitational guidance rather than an explosive, energetic outburst. The surrounding galaxy continued its slow, graceful aging, its stars tracing their ancient orbits, unaware of the potential for cataclysm that lay dormant at their core. The cluster itself, the great empire of 1,000 galaxies, seemed stable and peaceful. But the universe is never truly static. It is a realm of cycles, of slow, building pressures and sudden, violent releases. The peace of the Phoenix cluster was not a permanent state, it was an interlude. The very process that gave the cluster its form and structure was now conspiring to awaken the sleeping giant. A cosmic rain was beginning to fall, a gentle drizzle at first, but one that would soon become a deluge, aimed directly at the heart of the kingdom. The hunger of the central monarch was about to be answered. The great, glowing ocean of the intracluster medium was the key. This vast reservoir of gas, containing more mass than all the stars of the cluster combined, was in a constant, delicate battle with gravity. Its immense temperature, a staggering 50 to 100 million degrees Celsius, created an outward pressure that held the gas aloft, preventing it from collapsing under its own weight into the cluster's center. This equilibrium, however, was predicated on the gas remaining hot. But the ICM was constantly losing energy. Every second, it radiated away unfathomable amounts of power in the form of X-ray light, broadcasting its heat into the cold, empty void of intergalactic space. It was like a colossal, glowing ember slowly fading. This process of cooling is not uniform throughout the cluster. It is most pronounced at the very center, in the dense core surrounding the dominant galaxy, Phoenix A. Here, the gas is denser, and the cooling process is therefore much more efficient. As the gas in the core radiates away its thermal energy, it loses the pressure support that holds it up against the relentless pull of the central galaxy's gravity. The balance is broken. What follows is a slow, majestic, and utterly inevitable process known as a cooling flow. The cooled gas begins to sink, to fall out of the ICM and rain down upon the central galaxy. It is a gentle, cosmic precipitation at first, a flow of a few solar masses of gas per year. But over millions of years, this flow can become a torrent. This is the universe's great paradox of self-destruction. The very existence of these massive clusters, held together by gravity, creates the conditions for a process that threatens to overwhelm them. If left unchecked, this cooling flow would have dramatic, catastrophic consequences. Firstly, the immense influx of cool gas into the central galaxy would trigger a burst of star formation on an unprecedented scale. The galaxy would light up, forming thousands of new stars every year, a rate hundreds of times greater than in our own Milky Way. It would become a starburst galaxy of impossible luminosity, rapidly consuming its gas reserves in a brilliant, but ultimately unsustainable, cosmic firework display. We do not observe central cluster galaxies with such extreme star formation rates, which tells us that this runaway process must somehow be stopped. Secondly, and more critically for our story, a significant portion of this infalling river of gas would find its way to the very center, to the waiting maw of the supermassive black hole. The accretion disk, once a faint whisper, would swell into a roaring, brilliant inferno. The black hole would begin to feed at a voracious rate, growing in mass at a pace that would violate our understanding of galaxy and black hole coevolution. It would become impossibly large, its growth spiraling out of control, fundamentally altering the structure of its host galaxy. This scenario, the cooling flow problem, it was a major puzzle in astrophysics for decades. The theory was sound, the physics undeniable, yet the observational evidence was missing. Clusters were not collapsing in on themselves. Central galaxies were not glowing with the fire of 1,000 suns. Something was intervening. Something was fighting back against the inexorable pull of gravity and the slow decay of thermal energy. There had to be a heating mechanism, a cosmic thermostat that periodically kicks in to reheat the cooling gas, restoring the pressure balance and halting the flow. The universe required a feedback loop. The solution, it turned out, was the very monster that stood to benefit from the collapse, the supermassive black hole itself. It is the ultimate act of cosmic self-regulation. The black hole, when fed by the cooling flow, does not simply grow fat and dormant. The process of accretion is incredibly inefficient. As the accretion disk becomes engorged with matter, the intense magnetic and radiation pressures build to an intolerable degree. The system becomes unstable. It must release this excess energy. The black hole, in its feasting, awakens. It transitions from a quiescent, sleeping state to an active, violent one. It chokes on its meal and, in doing so, unleashes a torrent of energy back into its surroundings, an eruption so powerful it can reheat the entire core of the galaxy cluster. In the Phoenix cluster, the cooling was particularly extreme. Observations showed that the gas in its core was cooling and condensing at a prodigious rate, perhaps the highest ever recorded. The cosmic rain was becoming a monsoon. The stage was set for the thermostat to kick in, not with a gentle nudge, but with a cataclysmic blast. The inevitable hunger of the black hole was about to be met by an equally inevitable deluge of fuel, and the resulting collision of forces would create an explosion that would echo for eternity. The journey of the gas began in the vast, ethereal expanse of the intracluster medium, a slow, patient descent that would span millions of years. It was a pilgrimage of matter, drawn by an irresistible gravitational call. At first, the movement was almost imperceptible, a subtle drift in the tenuous, superheated plasma. But as it neared the central galaxy, the pace quickened. The river of cooling gas, now thousands of light-years wide, began to converge, its density increasing, its path narrowing toward the single point of ultimate gravity, the supermassive black hole. As the gas fell deeper into the gravitational well of Phoenix A, it was compressed, and a strange alchemy took place. Though it had cooled relative to the scorching ICM, the compression reheated it, causing it to glow. Filaments of warmer gas, like cosmic streamers, traced the path of the inflow, a visible testament to the galaxy's great inhalation. This infalling material did not simply rain down uniformly. It was a chaotic, turbulent cascade, shaped by the galaxy's own rotation and the complex magnetic fields that permeated its interstellar medium. Great clouds of gas, each containing the mass of millions of suns, collided and merged, their shockwaves sending ripples through the galactic core. The galaxy itself began to feel the strain. The delicate balance of its own ecosystem was being disrupted. The sudden influx of fresh, cool gas was a shock to its system, triggering pockets of intense star formation in the outer regions of the core. Clusters of brilliant, hot blue stars flared into existence, living fast and dying young, their lifetimes a brief flash against the backdrop of the galaxy's ancient, red stellar population. These were the sparks heralding the coming firestorm. But the ultimate destination for the heart of the flow was the central engine. The accretion disk around the supermassive black hole began to swell. The faint, glowing ring, once fed by a mere trickle, was now being force-fed by a raging torrent. It grew in size and luminosity, its temperature soaring. The whisper became a shout, then a roar. The disk blazed with the light of 1 trillion suns, becoming the most luminous object in the entire cluster. The quiet monarch was being awakened by an offering too vast to ignore. Within this incandescent vortex, the physical conditions became extreme. The plasma, swirling at relativistic speeds, generated magnetic fields of unimaginable strength. These fields, anchored in the disk but threading through the space around the black hole, were twisted by the rapid rotation into tight, helical coils, like immensely powerful magnetic springs. Energy was being stored, wound tighter and tighter with every particle that spiraled inward. The pressure mounted. The radiation pressure from the blazing disk became so intense that it began to act as a barrier, pushing back against the inflowing gas. The system was choking on its own fuel. The black hole could not accrete the material fast enough. A cosmic traffic jam was forming at the edge of eternity, a logjam of matter and energy at the event horizon. The sleeping tyrant was no longer slumbering. It was stirring, its immediate environment a maelstrom of light, magnetism, and gravitationally tortured matter. The very fabric of space-time around it was being stressed, warped by the growing concentration of mass and energy. The quiet hum of its existence had been replaced by a rising crescendo of power. The gathering storm had reached its peak. The system was now critically unstable, poised on the brink of a violent release. The magnetic springs were wound to their breaking point. The pressure had to be vented. The ancient peace of the Phoenix cluster was about to be shattered not by an external invader, but by a force from within, a necessary act of violence born from the universe's own inherent need for balance. The final moments before the eruption were a symphony of unimaginable physics, a silent, violent prelude to the loudest roar in cosmic history. The breaking point was reached. In the heart of the inferno, where the accretion disk meets the event horizon, the coiled magnetic fields, twisted beyond endurance, snapped. This was not a mechanical break, but a catastrophic reconfiguration of magnetic energy, a process known as magnetic reconnect ion. In that infinitesimal moment, the immense potential energy stored in the twisted fields was converted into kinetic energy with near-perfect efficiency. The loaded spring was released. What followed was not an explosion in the conventional sense, a chaotic burst of matter in all directions. It was a focused, directed, and terrifyingly powerful release of energy. The reconfiguring magnetic fields formed a tightly collimated funnel, a magnetic nozzle pointing away from the accretion disk along the black hole's axis of rotation. A torrent of charged particles, electrons and positrons, was captured by this newly formed magnetic channel and accelerated. Propelled by the immense power of the black hole's spin and the magnetic cataclysm, these particles were catapulted outward at velocities exceeding 999% the speed of light. A relativistic jet was born. Two of them, in fact. Twin beams of incandescent energy, diametrically opposed, erupted from the north and south poles of the black hole. They were cosmic blowtorches, pillars of pure energy and relativistic matter, narrower than a light-year at their base but carrying the power of 1 trillion suns. Their journey began in the most extreme environment in the universe, and their first obstacle was the dense, star-filled core of the galaxy Phoenix A itself. They punched through the interstellar medium with contemptuous ease, carving a path through clouds of gas and dust, ionizing everything in their wake. The material of the galaxy, caught in the jet's path, was swept aside, heated to millions of degrees, creating a shockwave that propagated through the galactic core. For the brief period the jets were active within the galaxy, they would have been a terrifying sight, two brilliant searchlights cutting through the ancient stellar haze. But the galaxy was just the first step. The true target of this eruption, the very reason for its existence, was the vast, cooling ocean of the intracluster medium. After traveling for thousands of light-years, the jets burst out of the confines of Phoenix A and into the far more tenuous, but far more expansive, ICM. Here, they met resistance. The hot, dense gas of the cluster's core pushed back against the jets, but the jets' momentum and energy were too great. They acted like cosmic pistons, relentlessly driving outward, pushing the ICM gas aside. The head of each jet formed a complex shock front, area hotspot where the relativistic particles slammed into the intracluster gas, heating it and sweeping it up into an expanding shell. This was the act of cosmic regulation in its most dramatic form. The black hole was not destroying its environment, it was saving it. The energy it was injecting into the ICM was precisely what was needed to counteract the cooling that had triggered the eruption in the first place. It was a direct injection of heat, delivered with surgical precision to the very heart of the cooling flow. The process was self-limiting. As the jets pushed the gas away from the galactic center, they cleared a path, starving the black hole of the very fuel that was powering them. The cooling flow was disrupted, the torrent of infalling gas cut off. The accretion disk, its fuel supply severed, would begin to dim. The engine of the jets would sputter and fade. The entire event, from the initial eruption to the cessation of the jets, likely lasted for millions, perhaps tens of millions, of years, a mere blink of an eye in the life of the cluster, but an epoch of unimaginable violence. During this time, the black hole in Phoenix A unleashed more energy than our own sun will in its entire 10 billion-year lifetime. It was an act of cosmic feedback, a necessary violence to restore balance. The sleeping tyrant had awakened, performed its vital, system-saving function, and in starving itself, had put itself back to sleep. The roar of the eruption would fade, but the evidence of its passage, the scars it left upon the cluster, would remain for hundreds of millions of years, a silent testament to the day the Phoenix truly earned its name. The jets themselves are long gone. The brilliant beams of relativistic light that tore through the cluster have faded, their energy dissipated over millions of years. But the consequences of their passage, the profound impact they had on their environment, remain etched into the structure of the Phoenix cluster. They left behind a ghost, a fossil record of their power, visible only to our X-ray eyes. When we look at the Phoenix cluster with telescopes like the Chandra X-ray Observatory, we see the glowing, superheated gas of the intracluster medium. But at the very center, flanking the galaxy Phoenix A, we see something extraordinary. There are two vast, dark patches in the X-ray emission. They are two enormous, symmetrical voids, regions where the hot gas appears to be missing. These are the cavities. They are the bubbles inflated by the black hole's jets. These are not true voids of empty space. They are filled with the remnants of the jets, a tenuous plasma of ultra-energetic, relativistic particles and powerful magnetic fields. This material does not glow in X-rays, and so the cavities appear as dark shadows against the bright backdrop of the ICM. They are the physical scars of the eruption, the hollowed-out spaces where the jets pushed the intracluster gas aside. And their scale is almost beyond belief. Each cavity is estimated to be over 300,000 light-years in diameter. Our own Milky Way galaxy, with its hundreds of billions of stars, could be placed inside one of these ghostly bubbles with room to spare. They are monuments to a force of nature operating on a galactic scale. The sheer size of these cavities allows astronomers to perform a remarkable calculation. By measuring the volume of the cavities and the pressure of the surrounding ICM gas, they can determine the amount of work the jets had to do to inflate them. It is a simple calculation of pressure times volume, the same physics that governs a piston in an engine. The result is a number that strains the limits of language. The energy required to create these voids is on the order of 10 to the power of 55 joules. It is a quantity of energy so vast that comparing it to terrestrial events is meaningless. It is hundreds of billions of times more powerful than a standard supernova. It is more energy than would be released if every single star in our galaxy were to suddenly explode at once. It dwarfs all other known black hole outbursts, making the previous record holder, the eruption in the cluster MS07356 plus 7421, seem modest by comparison. This is the source of the claim. The Phoenix A eruption is the most energetic cosmic event discovered since the Big Bang. It is the undisputed champion of cosmic outbursts. These cavities are not static relics. They are dynamic structures. Over millions of years, they have been rising buoyantly through the ICM, like bubbles rising in water, dragged upward by the cluster's gravity. As they rise, they drag behind them filaments of cooler gas pulled from the galactic center, enriching the outer regions of the cluster with heavy elements. They are cosmic dredgers, redistributing matter and energy throughout the system. Eventually, after hundreds of millions of years, these ghostly bubbles will dissipate. They will mix with the surrounding ICM, their relativistic particles will cool, and their magnetic fields will weaken. The scars will fade, and the cluster will return to a state of apparent peace. But the energy they imparted to the system will remain, having successfully reheated the core and staved off the cooling flow catastrophe for another epoch. The discovery of these cavities was a watershed moment in astrophysics. It was the smoking gun, the undeniable proof that supermassive black holes engage in this powerful feedback cycle. It solved the cooling flow problem in the most dramatic way imaginable. The universe's thermostat was not a gentle, warming glow. It was a pair of continent-sized blowtorches powered by a hungry black hole. The ghostly cavities of Phoenix A are more than just a scientific curiosity. They are a profound reminder of the scales of power that operate in the cosmos. They are a testament to a cycle of destruction and regulation that is fundamental to the evolution of the largest structures in the universe. They are the quiet, dark echoes of a roar that once filled a kingdom of galaxies. The eruption of Phoenix A did more than just carve out two colossal cavities in the intracluster medium. The initial blast, the moment the jets slammed into the dense gas of the cluster's core, was an event of such violence that it sent a powerful disturbance propagating outward in all directions. It was a shockwave, a ripple in the pressure and density of the ICM, traveling away from the central galaxy like the wave from a stone dropped in a pond. But in the plasma of the ICM, a pressure wave is something else. It is a sound wave. The black hole's outburst created a sound, a note of such profound depth and power that it resonated through the entire core of the galaxy cluster. This was not sound in the terrestrial sense, of course. There is no air to carry it, and its frequency is far too low for any biological ear to perceive. The rapidity of this cosmic note is determined by the size of the cavity and the time it takes for a pressure wave to travel across it. For a similar, smaller eruption observed in the Perseus galaxy cluster, astronomers were able to calculate this frequency. The note produced was a B-flat, but one that was 57 octaves below middle C. Its period, the time between one wave crest and the next, was nearly 10 million years. This is a sound so deep it is almost indistinguishable from the slow passage of time itself. The sound wave from the Phoenix eruption would have been even deeper, even more powerful. This cosmic hum, this infrasound of the gods, is the primary mechanism for distributing the black hole's energy throughout the cluster core. The jets provide the initial, focused blast, but it is the subsequent sound waves that gently and evenly reheat the surrounding gas. As the wave propagates outward, its energy is slowly dissipated into the ICM, absorbed as heat. It is a gentle, persistent warming, like a low-frequency hum that vibrates and warms an entire room. This process is far more efficient at heating a large volume of gas than the direct impact of the jets alone. It is the universe's solution to an energy distribution problem. The sound waves are the messengers, carrying the energy from the central engine to the distant provinces of the kingdom, ensuring that the entire core is stabilized, not just the regions immediately adjacent to the jets. We can see the evidence of these sound waves today. In the detailed X-ray maps of some galaxy clusters, we can observe faint, concentric rings or ripples in the gas, like ripples on a cosmic pond. These are the crests of the sound waves, frozen in time by the immense distances and timescales involved. They are the cosmic echoes of past eruptions, a visible record of the sound that still reverberates through these ancient systems. The Phoenix cluster's eruption was so powerful that the initial shockwave would have been immense. It would have swept through the inner cluster, a wall of compressed, superheated gas, instantly raising the temperature of the ICM by millions of degrees and halting the cooling flow in its tracks. This initial, violent shock would then have settled into the more gentle, persistent ringing of the sound waves, which continue to echo and distribute their energy to this day. This discovery adds another layer of profound, poetic beauty to the science. The universe is not a silent movie. It is a grand, slow-motion symphony of immense power. The great clusters of galaxies are not just cities of light, they are cosmic resonant chambers, ringing with the deep notes of their central black holes. The cycle of feedback is a conversation. The cooling gas whispers its presence to the black hole, and the black hole roars its response, a response that is carried on the waves of cosmic sound to every corner of its domain. It is a dialogue between gravity and energy, between collapse and rebirth, a rhythmic pulse that has governed the lives of these massive structures for billions of years. The sound of Phoenix A was the deepest and loudest note in that symphony, a fundamental tone that reset the rhythm of an entire cosmic empire and whose echoes are a permanent part of the cluster's very being. The name of Phoenix E was given to the cluster for its remarkable properties long before the full story of its eruption was understood. It was named for the mythological bird that is reborn from the ashes of its own destruction. The name proved to be more prescient, more profoundly accurate, than its coiners could have ever imagined. The Great Eruption, an act of seemingly unparalleled destruction, was, in fact, the ultimate act of preservation and rebirth. It was the cluster setting itself on fire to avoid a greater death. Had the eruption not occurred, the cooling flow would have continued unchecked. The central galaxy, Phoenix A, would have undergone a runaway starburst, converting its vast reserves of gas into stars with furious inefficiency. It would have blazed brightly for a cosmic moment before exhausting its fuel, leaving behind a bloated, star-choked relic, its potential for future generations of star formation spent. The supermassive black hole, for its part, would have grown to a truly monstrous size, far exceeding the established relationship between a black hole and its host galaxy, potentially destabilizing the entire galactic core. The cluster would have become unbalanced, its central regions collapsing into a state of premature decay. The eruption was the cluster's immune response. It was a violent, necessary fever that purged the system of its sickness. By injecting a colossal amount of energy back into the intracluster medium, the jets and their subsequent sound waves reheated the gas, restoring the thermal pressure that holds it up against gravity. The cooling flow was halted, the deluge of fuel cut off. The runaway star formation was quenched, and the black hole was put back on its starvation diet. The act of destruction saved the system from itself. This is the Phoenix cycle, the great feedback loop that governs the evolution of the most massive structures in the universe. It is an eternal rhythm of cosmic life. Over the next few 100 million years, the energy from the eruption will slowly radiate away. The ICM will once again begin to cool. The pressure will drop, and gravity will reassert its dominance. A new cooling flow will begin, a gentle rain at first, then a growing stream, then a river, all flowing once again toward the galactic center. The central black hole, after its long slumber, will begin to feed again. The accretion disk will brighten, the magnetic fields will twist, and the pressure will build. And then, one day, another eruption will occur. It may not be as powerful as the last, but it will be powerful enough. It will once again reheat the core, push back the gas, and reset the clock. This cycle, this cosmic heartbeat of cooling and heating, of inflow and outburst, has likely occurred dozens of times over the Phoenix cluster's 13 billion-year history. We are merely witnessing the aftermath of its most recent, and most powerful, beat. This cycle is not just about preservation, it is also about creation. The periodic reheating of the ICM prevents all the gas from being consumed in one catastrophic burst. It regulates the fuel supply, ensuring that the central galaxy can continue to form stars at a slow, sustainable rate for billions of years to come. The heavy elements forged in those stars and expelled by supernovae are then redistributed throughout the cluster by the black hole's outflows, enriching the cosmic medium and providing the raw materials for future generations of stars and, perhaps, planets and life. The black hole, often cast as a villain of cosmic stories, is revealed here as a vital architect, a galactic gardener that violently prunes the system to ensure its long-term health and fertility. It is the heart of the cluster, pumping energy instead of blood, its rhythmic outbursts driving the circulation of matter and regulating the entire ecosystem. The legacy of the Phoenix eruption is the continued existence of the cluster in a stable, long-lived state. The ghostly cavities are a monument to this process, a reminder that the apparent peace of the cosmos is often a hard one, temporary truce in an eternal war between gravity and energy. The Phoenix did not die and was not reborn from ashes. Instead, it faced its own inevitable self-destruction and, with a roar of unimaginable power, chose to live. We have journeyed across billions of light-years and billions of years into the past, to the heart of a cosmic kingdom ruled by a force beyond our everyday comprehension. We sought the source of the greatest explosion since the dawn of time, and we found it not in the brilliant death of a star, but in the violent awakening of a slumbering monster at the center of a galaxy. The core mystery is resolved. The colossal eruption from Phoenix A was not an act of random chaos, but a vital, necessary component of a cosmic feedback loop. It was the universe's self-regulation mechanism, a planetary-scale thermostat kicking in to prevent a runaway collapse that would have consumed a galaxy and unbalanced a cluster. The supermassive black hole, fed by a torrent of cooling gas, unleashed a torrent of its own, pure energy, focused into relativistic jets that carved cavities in space and sent sound waves echoing through the void for millions of years. It was an act of destruction that served the ultimate purpose of preservation. In this story, we see the universe for what it truly is, a dynamic, interconnected system, a web of cause and effect playing out on majestic scales. The laws of physics, gravity, thermodynamics, magnetism, are the authors of this grand narrative. They write the rules of the cycle, the slow cooling, the inevitable infall of matter, the build-up of pressure, and the violent, restorative release. The Phoenix cluster is just one actor on this cosmic stage, but its performance was a masterpiece of power, a definitive demonstration of this fundamental process. We see that the universe is not destined for a simple, quiet decay. It fights back against entropy. It has mechanisms to maintain balance, to prolong the existence of its most magnificent structures. The cycle of the phoenix, this rhythmic heartbeat of destruction and rebirth, ensures that these great cities of galaxies can endure for trillions of years, long after the last stars and galaxies like our own have faded away. This is not a story of a distant, alien phenomenon. It is a story about the fundamental architecture of our reality. A smaller, quieter version of this same feedback process is happening in our own Milky Way, and in nearly every massive galaxy we observe. The eruption in the Phoenix cluster is simply the most extreme example we have yet found, a glimpse of the upper limits of power that the universe can unleash. We began with a serene image of a distant cluster of galaxies and found beneath it a history of violence and a future of endless cycles. We saw that even in the darkest hearts of galaxies, in the points of infinite gravity, there is a force that can give back to the universe, shaping and sustaining the very structures that house it. It is a profound and humbling realization. It recasts our understanding of black holes from simple agents of consumption to complex engines of cosmic regulation. Now, as our journey concludes, take a moment. Picture that scene, 57 billion years ago. Imagine a vantage point, safe in the void, watching as two pillars of light, brighter than a trillion suns, erupt from the heart of a galaxy, tearing through space and pushing back an ocean of fire. What would you have done if you could witness it? Would you have felt terror at the roar, untamable power? Or would you have felt a sense of awe, a deep, reverential wonder at witnessing the universe correcting itself, at watching the great cosmic engine perform its vital, violent, and beautiful work?